All right, let's dive right in. Today we're talking about a pretty wild idea for how we might actually get to artificial general intelligence, AGI. And it's a framework that says the answer isn't just about building bigger and bigger models, but about creating a smarter, self-evolving system. This is some cool stuff, so let's get into it.
AI is absolutely everywhere right now. It's in the headlines, it's on our phones. But what if, and this is the big question here, what if the whole thing is built on a cracked foundation? What if, for all their power, today's AI models have a fundamental flaw that's holding them back from becoming truly intelligent?
So, to start, we've got to look at the state of AI right now. What's popular, what works, but also what might be a little fragile. It's time to go looking for those hidden cracks in the system.
Okay, so you've got these incredible models like ChatGPT. And yeah, they're powerful. But experts call them narrow AI. Think of them as hyper-specialized tools. They're masters at recognizing patterns in language, but they're not general thinkers. They can write a beautiful poem about a sunset, but they have zero real understanding of what a sunset actually is.
And when you look closer, those cracks start to look pretty deep. First off, the cost. The sheer amount of computing power and energy these things need is just getting out of hand. They're also incredibly data hungry, and we might literally run out of high-quality data to feed them. And maybe the biggest issue? They hallucinate. They make things up with this baffling confidence. And that's because they don't have any real-world grounding, no concept of cause and effect, which makes them these mysterious black boxes we can't fully trust.
Now here's the real kicker. These aren't just a bunch of separate problems you can fix one by one. Nope. They're all connected, tangled up in this single, massive challenge. And this framework gives it a pretty cool name, the three-body problem of AGI.
So here's how it all locks together. First, you've got the hardware problem. Our brilliant AI software is basically stuck running on these static and flexible computer chips. That leads right to the learning problem. Because the hardware is inefficient, the models have to learn from these giant static data sets instead of, from the real world. And that kind of passive learning is exactly why we have the common sense problem. The AI has no physical, grounded way to understand reality. See? You can't fix one without fixing them all.
So, how in the world do you solve a problem that's so tangled up? Well, you don't. You don't tackle it piece by piece. You come up with a single, elegant solution that flips the whole system on its head. And that solution is called the Virtuous cycle.
So, the solution is a loop, a cycle with three parts that all feed into each other. Step 1, the AI designs its own better hardware. Step 2, that new hardware lets it learn in a totally new way through physical interaction. And step 3, this rich, real-world learning builds a true understanding of context, which, you guessed it, lets the AI design even better hardware. It's a cycle of recursive self-improvement.
Let's break that down, because that first step is maybe the most mind-bending part of this whole thing. Hardware that literally evolves itself. This is a seriously radical idea. Instead of human engineers designing chips for an AI, the AI looks at its own internal processes, finds its own bottlenecks, and then designs the perfect hardware for its own needs. The AI literally becomes its own architect.
This is a complete paradigm shift. Right now, hardware is a fixed bottleneck. It's a wall. But in this new model, the hardware becomes just another parameter that the AI can learn and optimize. The AI isn't just learning how to write better software anymore. It's learning how to build the best possible physical brain to run that software on.
And look, this isn't just science fiction. This idea is built on real tech that's out there right now. We already have reconfigurable hardware, like FPGAs. We have brain-inspired neuromorphic chips. And there's this whole field called AI for EDA. That's electronic design automation, where companies are already using AI to help design better chips. This is just taking that idea to its ultimate logical conclusion.
So, once the AI can build itself a better brain, what's next? What does it do with that new power? Well, that brings us to the second part of the cycle, where the AI starts to learn about the world, not like a machine, but more like a toddler.
What this means is you take the AI out of the data center, and you put it inside a body, a robot body, with sensors for sight, touch, hearing, the whole shebang. It stops learning passively by just reading a frozen copy of the internet. Instead, it learns by actively going out and exploring the physical world, creating its own endless stream of real-time data.
And this is where that toddler analogy really clicks. It's such a great way to think about it, right? A child learns what a dog is by seeing one, hearing it bark, maybe petting its fur. It's this rich, multi-sensory experience, and they learn incredibly fast without needing to see a million labeled pictures of dogs.
That's exactly the kind of efficiency we're aiming for here.
This approach just completely sidesteps the whole learning problem. The AI escapes the tyranny of big data because the real world is an infinite source of new things to learn. And get this, the data it creates is perfectly labeled by default. The sight of a ball, the sound it makes when it bounces, the feeling of catching it, all that data is experienced together, automatically connected. That's a world away from the messy, disconnected data we use today.
So this new way of learning, through a body, leads us directly to the final and maybe most important piece of the puzzle, forging genuine common sense. That one thing that's so obviously missing from today's AI.
It gets there through something called cross-modal inference. You can just think of it as the AI learning to connect the dots between its different senses. It starts building an internal model of reality, a predictive one, by figuring out how sight and sound and touch all relate to each other. It learns that the image of a glass falling is always followed by a specific sound.
And this is where real understanding comes from. The AI learns that fire is hot, not because it read it in a book, but because it can correlate the sight of a flame with data from a thermal sensor. It can look at a metal object and predict, that's probably going to feel cold and hard. This creates a built-in fact checker. If the AI starts to hallucinate something that breaks the laws of physics, its own senses scream error, forcing it to correct itself.
And that brings us full circle. A better understanding of the world lets the AI design smarter algorithms. Those smarter algorithms let it design more efficient hardware. That better hardware lets it explore and learn from the world even faster. And that deeper learning builds an even richer understanding. Each part of the cycle just fuels the next, creating this incredible, accelerating feedback loop of intelligence.
So in the end, this framework isn't just about doing more of what we're already doing. It's a path to a totally new kind of intelligence, one that evolves its own mind and its own body together. And that leaves us with a pretty profound question to chew on. If an AI can actually learn to design its own brain, what are the true limits of intelligence?